My name is Ray, and now I'm a second-year master's in Professor Sasha Hilgenfeld's group.
Hi, my name is Ashan Bakrasi, and I work in the Advanced Controls Research Laboratory at the University of Illinois.
Hi, I'm Peter Knapp. I'm a first-year graduate student in the NAM group.
My name is Professor Mariana Kirsch in Mechanical Science and Engineering. I run the Tissue Biomechanics Lab here at UIUC.
And nowadays our group is working on, the bubble microfluid.
In the controls laboratory, we create control algorithms that drive control systems that can be used for a variety of applications.
I work with crumpled graphene, and I'm really interested in applications in optics.
We're interested in understanding the mechanical properties of musculoskeletal tissues in an effort to improve the treatment and intervention of musculoskeletal diseases such as osteoporosis and osteoarthritis.
So our group works both on, theoretical, experimental, and numerical. So
what we're working on right now is a collision avoidance system for different drones where you throw something at the drone and it avoids it. And we write the mathematical formula that goes behind that.
So basically, I want to see if you crumple graphene, if it changes the way it absorbs light, or if light will weirdly couple to the surface, and you can use that for some sort of novel sensor for chemicals or for radiation. And it's really interesting.
So we use a combination of experimental techniques to get those mechanical properties, and then combine those with computational models to actually tease out which parameters we should be focusing on to better understand the mechanics of, in this case, the shoulder joint or the wrist joint or bone biomechanics, and for example, why bone breaks.
simply speaking, like if you have a mixing of the particle solution with different sizes, like let's say if you have 10 microns with 5 microns particles mixed together, and by infuse them, pass through the bubble, you can efficiently sort them to some different outlets.
So right now we're working on a couple projects for strain actuated photosensors. So you can track what type of wavelengths of light, but depending upon how you stretch a sample, and then you could use that either to determine wavelengths of incident light, or you can use it as a sort of backward strain sensor.
For example, what we do with this model is we work with an orthopedic surgeon to try and help him basically optimize surgical technique, right? So we're trying to understand what things he can do in the OR that would improve the final patient outcome to restore their overall joint movement.
Our system to some other applications like micro mixing, which is also a pretty good perspective for the future. And nowadays we are working on some biological objects for still using our system. Like we worked on some blood cells, we worked on E. coli, we worked on some archaeas and some viruses. So basically, that's pretty much what we are working on.
So controls in itself can be used for anything, and we develop the theory that goes behind all these applications. And once we have a good theory base, we're constantly talking to each other and thinking about where it can be applied in the real world.
And then on another side, in the bone case, then we are looking at improving interventions or diagnostic techniques to detect the risk of fracture, in this case of bone.
Cool.
Oh, absolutely not. No research for me.
Why don't you like research?
I don't know. It doesn't appeal to me.
I hate research.